Well, hi, good morning. Thanks for coming and joining me in my shop here. I'm about to start on that very old radio. This is out of the 1930s. But just before we get looking at it, I've got something else to show you I think you might find interesting. So if you are certainly in Canada, you've been using some schematics that have come from books called RCC books. Well, you get these off the internet quite easily, one sheet at a time. But I'm going to show you what an actual RCC book looks like. I happen to have one. Someone has given me one. Check this out. So these books would commonly be found in repair shops here in Canada. What they were doing was the Radio College of Canada was issuing these books. You could buy into their service. I think you get a book every year or two with more schematics in it. Something like that. I don't really know for sure. And you'd probably get sent updates. Radio College of Canada, Toronto, Ontario. The symbol of the capacitor here. RCC. In hoc sino vinces. Okay, no idea what that means. We open it up. The first thing you get is an index. Let's see if I can get a little closer here. Radio College of Canada Circuit Manual, Index of 1939 to 40 series. These are all the radios that were made in Canada during those years. Page 1, Index so-and-so. Northern Electric, Marconi, Crosley, Canadian General Electric. So here's the index sheets. And then we get into the actual schematics. And you may have seen these. Look, the first one is the nipper. How do you like that? So this is not a photocopy. This is what was really issued out. So this book, I think I know where this book was. And if you've been doing this work, and if you're in Canada in particular, you've looked through these on the internet. Now halfway through, there's another index page somewhere in here. More than halfway through. Okay, so I'm not going to find. There's another index page in here anyway, and that just covers the next year's models. But in the middle of this book, I found this page. Ferguson Radio Service. Ferguson is a place here. Phone Meaford 288. What kind of a phone number is that? Meaford 288. All types of radios serviced and repaired. Service you appreciate. Just a radio service. Huh? Yeah, this is just a sheet of paper that was in here, and look what somebody. This is probably done by Leslie J. Ferguson, proprietor. I think this was probably done in the 40s. Drew all this up. Nice job. I looked at it very carefully. It very, very carefully drew this. A very serious attempt at something. The Ford Philco F1841. This must be the vibrator here or something. I thought that was interesting anyway. So there we are. So any repair shop in Canada, in the United States there were organizations like SAMS doing the same sort of thing. Any repair shop in Canada would have to have a set of these books because the internet wasn't going to do it for you back then, was it? So there we are. So now you see these sheets on the internet. Now you've seen them where they really come from. These books were worth a fortune. I mean, you couldn't run the business without them. Okay, let's take a look at this radio. All I've done is bring it in here and sigh over the amount of dirt that's on this radio. This is one filthy radio. It's a really filthy radio. Holy smokes. I've done nothing with it except what you see me doing now. Oh boy, it's full of cobwebs all through here. Now you can't even tell there's wires on this. There's so much dust. Oh boy, oh boy. See, this tube here I can see is shoved in past a tube shield clip. And the shield clip is pushed back and the tube is on a bit of an angle. A little bit of tape on here for some useless reason. So this radio's come to me. I have the cabinet for it. The cabinet is in rough shape. But the owner has every intention of restoring the cabinet to like new condition, and he'd like this radio to be similar. So I've already pointed out to him that the back of the plate here is deteriorating. There's a little bit of paint coming off up at the high parts here, which is a sign of things to come. So that's something we have to be extremely careful of in this radio. It would strike me that any contact with the back of this plate is going to flip the paint off. Hope not, because it's a nice dial, and the dial is a big part of this radio, of course. Stewart Warner. Magic dial. Why would they call it a magic dial? What's magic about it? Magic dial. I don't see any magic. Magic eye would be magic. I don't see any magic eye in here. Looks like there's more paint damage down here. Let's put a light behind it and just see what comes through. You see all up in here. Yeah. Well, it is what it is. It's not so. Well, I will think about what can be done to improve it, but I don't think anything can be done. There's two lights back here, and they're just going to blast. If the paint is damaged near the lights, it's going to blast right through. Okay. Can't do much with all this dust on here. So my normal practice is to get a vacuum and a paintbrush and just knock the paint off. Here's an interesting thing right here. This looks like a gimmick capacitor with just some wire wrapped around the post here. Something different. If we get around the back of it, it's got a monstrously long cord here. Oops. It's kind of like original wire, Oh my gosh. Okay. Well, there's a scary one for sure. This is bad enough. I'm going to put it on the close-up camera. Let's take a look at this. This is what you do not want to see. You do not want to see something like that. Just going to give myself a little bit better focus here. Just bear with me for a moment. Okay, we'll focus in a little closer to it. So how many things are wrong with this? Wow, this is a great example of what not to do. It's actually an attempt to do it the right way, too. Surprisingly enough. So the wires are coming up the middle, of course, and he's done the right thing here by sweeping them around the outside of this. They come up, they come around the outside, and they reach the screw. You reach the screw on the outside and come around this way, and then you're going under the screw the same way the screw turns, which is key, right? Everybody knows that, don't they? That you have to put the wire under the screw the way the screw turns down, or the wire will be pushed out every time you tighten the screw. The problem is, whoever did it took way too much insulation off. This should all be insulated here. Consequently, you've got copper, bare copper, getting right down into here. Look at the other side's no better. He comes around the outside, very good. Way too much insulation removed. Sticks it under here, look at this, loose. This is bad, this is all bad. This is how you're going to get a whopper of a shock off of this. So these wires are sticking out a little bit here and over here, and you grab the plug like, a little hard to do in the close-up, grab it like this and manage to contact those wires from both prongs Yow! Another thing too is that, you know, inevitably these guys get tugged on, right? As much as we're not supposed to. We tug on these things. And it's going to pull it further and further down and increase the chance of a short in there. Yeah, this is really very, very bad. So we're not about to plug it in, so I'm not going to do anything about it right now, but I've certainly noticed it. Let's take a look at the speaker here. This is a big honker. Huh. Okay. So here's another great wiring job done here. These are soldered, and then this is friction tape, and it's come off. That's a little unusual. Usually the friction tape, for some reason, lasts a long time, but not in this case. So this is malarkey. All of this. Nothing here. Now the thing about these speakers, so if you see 2 wires coming to a speaker, you can probably relax. If you see 3 or 4 coming, don't relax because they've got high voltage on them. Wow, it's just piles of dirt here. So plugging this radio in the condition it's in, wow, yeah, would just be these things shorting out. Oh boy, oh boy. It's really in rough shape at this point. And it's not even all here. Let's look at the speaker column, because I already know what we're going to see. Okay, I did not do this. I did not do that. I did not do that. I did not do this crack. There's a crack right through here. Probably look close. There's probably more radial cracks in it. I don't actually see any, just here. There's a pretty big one here though. Big beautiful speaker. Don't know the condition of it offhand. But it wants to sing, that's for sure. Why don't we take that cover off? Find out what's under here. I don't think I got one that big. Huh, I do. Felt like it was getting tighter. Felt like the whole screw was turning. No, this. What is under this great big cover? Another set of joints. The transformer is here underneath the cover, the output transformer. Somebody scratched the word red in here, and over here they scratched, well, I can't read it right now. Let's spin this around. Spider eggs. What's that? This guy doesn't look original because it appears to be screwed in one spot and stuck in. That's odd. That's quite odd. I mean, this speaker has come from another radio potentially. It fit in there just fine. The screw holes lined up. I don't think it's from another radio, but this is odd. This is quite a strange arrangement up here too. It's quite an odd arrangement. This is the kind of thing you do to to mount a bracket like that. I don't know. I don't know what you do. What are you doing there? What's going on? See this must be the two voice coil contacts here. We've got something soldered right to the frame here. It says yellow. That's what that says. Red and yellow. What's red and what's yellow? That's kind of odd, isn't it? Okay, I don't think we're going to get much more out of that. That is the speaker. Back to the radio. So the radio has a bottom plate. I noticed when I was carrying it over here. Let me just put this. Let's just. Do we dare look underneath this thing? Well, we have to sooner or later, that's for sure. Pretty tempted to cut these, but I think it would be premature. Transformers here. If we flip it right over, it ends up sitting on this, and over here. Yeah, I'm not sure I want to flip it right upside down. What's this great big plate here? Hey, why don't we try tuning? No one's tried tuning this radio yet. How do you tune it? Must be with this one. There it goes. Very interesting. Okay, so this is very interesting. So I've had two very large military radios in my shop the last while. The first one, it's called a Hammerland SP600. Inside it has a round wheel, thin metal wheel, very much like this. And up against it is a roller that turns with the control here. Same as this radio, you'll see in a moment. And it's just a friction contact. So when you reach the end of the road, and this plate can't turn anymore because it's at the end, but you can still turn the wheel, it just skids. And you can feel you're at the end and it's skidding. And that's the alternative to a string. Do it this way. Here. Here's the plate here. Very hard to see in here. Well, you know, let's switch cameras here. So there's no string. I mean, that's the good news about this radio. Here's the plate. And down in here, what is all that? This looks like some kind of sunken ship debris. So that's a spring clip there. So the spring clip, you can see it's pushing the rod I'm turning, the shaft I'm turning. It's pushing it against the edge of the plate. Here. Wow, you'd think those springs wouldn't be around now. Wow, that's quite something. Surprise. It's very stiff tuning here. It's pretty hard to turn. So zero spring stretch or string stretch, spring stretch either. So no backlash in the tuning. So I think that's the advantage. No backlash. Let's just keep going with this guy. Oh my gosh. So I was thinking about washing this radio. I've never washed a radio, but I've certainly read about people who would take something like this and just hose it down and then dry it off quickly. I'm pondering that, because how am I going to get all this dust off of here? Holy smokes. The problem with the water is it's going to get places where you really don't want water, like right in this thing, or in this cardboard, essentially cardboard tube here. I guess briefly wouldn't matter much. I also have forced air. It's not very strong. I have a little bit of forced air and the vacuum, of course, instead of water. You know, this is, I clearly try it with the brush and the vacuum the usual way first. And if you're not happy, maybe then water. A lot of dust down inside these things, I would imagine, through those holes. There's this much on top. Oh, I've got to clean that one. Huh. It doesn't attract dust. Copper's very, very clean. There's a capacitor here. Just worried about how much dust is in there. You know, would dust really affect this? Hey, there's 3 sections. It's a 3-section capacitor. The radio has some good potential. A lot of rust on the steel parts. But in a humid environment. Been in a filthy, dirty human environment. Human. That's true. A human environment. I'm just trying to move things around here so we can. Oh gosh. Oh. Yeah, you can't see anything what just happened. It was rather humorous though. Well, my camera fell on the floor. I have more than one camera. The humorous thing was I picked this big speaker up and stuck out of sight by this big magnet was this thing on the speaker. Very humorous stuff. Thank you again to the person who sent me this. Okay. Well, there's something missing here. I'm guessing it's a vacuum tube. So we've got the detector tube there. This looks like an output tube, probably a 6K6 or something like that. And we have these metallized tubes. Yet this one has a shield spring clip. So I guess the original tube here must have been glass with a shield over it. These ones must have been the size they are because no, they could have been bigger, taller. Glass tubes originally. I don't know when these metallized tubes came out. It was pretty early on though. Well, what do we got here? Something hanging out. And a big nameplate here. Ground. So I think a screw is missing from here. And this is probably the wire that was on the screw. It's just pulled through. And I'm destined to change this, obviously. We're not going to use this as a power cord. But I don't think this is a joint. They just tape together here. They tape together periodically. Okay, what's on this nameplate? Let's get the shoe camera. Serial number 64222. You really think they made 64,000 of these? Stewart Warner Faradyne. So they're still naming the radio at this point. There were a lot of Odyne radios built in the 20s. Faradyne. So Faro obviously is a reference to steel. Where exactly would the Faradyneness come from? I don't know. Licensed by the Canadian Radio Patents Limited, only for the non-commercial reception of public radio telephone broadcasts. 32. HEPC stands for Hydroelectric Power Commission of Ontario, is what that actually stands for. 25 or 60 cycles, 64 watts. Belleville, Ontario, made in Ontario. Stewart Warner Alamite Corporation of Canada, Mr. Alamite got on board there, I guess. You could see the technology. Okay, that's all we're going to get out of that. Now here's one really curious part. I don't know what this is. What is this? It's a cover of something. What would it be a cover of? Has a label on it. Oh. Disconnect. Huh? Disconnect cord? Before? Disconnect cord before opening this up to look inside. Piece of paper there. That's this stuff from up here. Oh, yeah, don't blow on it. That's stupid. Tried to blow the piece of paper out of there. Hey, let's open this up and see what it is. You know what? This could be where the gold bars have been hidden. Always looking for the gold bars. This would be a good spot to hide it. I mean, who would look under here for a gold bar? It'll have to be kind of a small gold bar. Aha! I suspected it might be a fuse. Aha! Interesting that they put it under a cover, but I guess it's because these terminals are here. Let's take a look at it. Wow, you can definitely see some copper corrosion. So you'd have to guess those clamps are plated copper. And the plating has given out in a few little spots. And so you see copper corroding. That's my guess. The corrosion actually falls off and is collecting on the bottom. So that would be copper, probably copper chloride, but it could be copper sulfate, could be copper almost anything. The fuse itself looks like it's in there. That's a big honking fuse. Well, I'm looking at it with a close-up camera, maybe it's not so big and honking. It's kind of stuck in there. I don't want to break it. That's a big fuse. That's a big fuse. Let's look at it again here. Well, that's like 20 amps to 25 volts. I think you can classify this as an automobile fuse. Yeah. 20 amps, 25 volts. Well, this ain't gonna blow, I don't think. It's probably fine, at 100 volts. It's probably not an issue, but 25 amps, not protecting much with that. Okay, before I start my usual routine of losing screws and nuts and everything, put these back on here. I don't know what tube's in there, but I'm sure I can get a schematic for this guy. We gotta look under the plate now. What little secrets go? Oh, that's where the gold is gonna be. See, put it under here. So this has got a plate that comes up the sides. So a lot of radios, I'm really anxious to get them operating in any amount as quickly as possible, so I can get something happening between the antenna and the speaker. Even if it's just, I'm a lot happier. So usually my process is, check the radio out, see if there's something glaringly wrong with it that would make you scared to plug it in, and as soon as you think it's safe enough, plug it in with some control, right? Not this one. This one, I think we're quite a ways from plugging this guy in. You never know, though. So, okay, who wants to wager? Are the parts original under here, or have they been changed? Okay, I should have 4 screws here. 2, 3, 4. There, this is a special container I use to lose the screws in. Now, the plate here. So this just isn't quite as easy to get this off. Now, there could be some more screws. Did they do that? Did they put screws underneath it? Maybe it's going to fall right off now. I can pick it up by the transformer and pull this off. Just drop off. Okay, looking inside for any hints of where, like a map to the gold. Maybe there's a map. Big hole in the bottom. Big hole. Probably giving access to something. So something can be done to this radio with the plate on it. Some kind of adjustment or something. And we're going to flip it up, transformer side down, and all will be revealed. Has anybody worked on this thing? This sure is jumping out. This big green thing. Hard to know for sure, but it looks mostly original, I think, except for this green one. To me doesn't look original. It could still be. I could just be wrong about it. Sangamo. This is gonna fall over. It's not stable. Thin block, which I don't think I have. Okay, there's another way. Okay, that's stable. Let's get the close-up camera and look through this and see what we're in for here. Just start in the lower part. What's another one of these? Another box. What's this box? So this is a capacitor, is what this is. I'm pretty sure. The information on it. One terminal, so it's screwed to the chassis. It's riveted to the chassis. Rivet connections are questionable, always questionable. Normally, or not normally, but often you'll see these kinds of things soldered in too, because the manufacturers knew they couldn't rely on the rivet. So it could be trouble there. It looks good, but it could be trouble. The other side riveted too, probably. Let me see it up in here. I think that's the rivet, right there. Okay. Right off the bat, found something interesting. Come over here. Power cord coming in. So there's a resistor there, losing its paint. I can't say I've seen one looking exactly like that before. Doesn't mean it's bad, but certainly not the most positive thing. Look at the insulation on that pinkish wire. Looks like it shrunk it down onto the conductors. Something weird going on with it. Here's the wires coming out of the transformer here. As usual, they've got a little bit of tar or whatever it is that's in the transformer. It's kind of leaked down a little bit, I think. So these are as hard as can be. You don't even want to squeeze them for fear of crack. And then a short circuit not far behind. Generally speaking, the wires are bound to be pretty stiff in here. It's got these nice big cloth ones though. That's not bad. Yeah, that's pretty flexible. Oddly enough, sometimes the older wire is more flexible. It's got some of this blue crap in here. The blue wire may even be green. $10 says if you try to bend that, whew, the plastic gonna come right off it. Let's see. Oh, it just feels rock solid. There's a bunch of it over here. So the thing about this, if you're going to work on the radio and you start moving these wires, the insulation will crack off of them, and now you got a new project in the radio. And if you're trying, if your objective is to basically renew everything, then what does it matter? But if your objective is just to make the radio work, you get yourself into a real jackpot pretty quick with these stiff wires. Now, that's interesting looking, fancied up capacitor there. Lots of stuff written on it. Very bare. Vera something. You see the end of this capacitor looks open, so if there's any moisture around, and goodness knows there has been, it's gone in there, and this capacitor is a shot. Of course, this capacitor at this age, the moisture is going to go right through the outside anyway. And look at the wax. What wax exactly? Where's the wax? Stewart Warner. So they labeled their capacitors. Foil in, made in Canada. This is a solar, sealed tight. Yeah, don't kid yourself. Sealed tight. It says right on it, just not, you're not confused. Paper capacitor. You don't see any. That's a nice looking resistor. Beautifully shiny. Look at clean. Oh, pretty clean. In a radio like this, the high voltage wires will collect dust faster than the rest. And sometimes you can pick out the high voltage wires just from the dust. High voltage circuits. It just doesn't have that factory look to it. Is that a replacement then? This might be a replacement right here. It looks like it's been resoldered, sort of tacked in there. Okay, up. That's the one that needs to be adjusted through the hole. I would imagine. The idea of sticking a screwdriver or anything up through a hole into the back of a radio, you can't see where you're going with it. That's a hint that you can't align this radio without the back on. The bottom plate. Well, you shouldn't. You certainly can, but you shouldn't. And the high wattage resistor. It's kind of in the wrong part of the radio. What's it doing down here? that a replacement? There's this capacitor. And a dead spider hanging from it. Is that a replacement? It has the look. I think it's a replacement. And this looks like a replacement. And it's kind of weird. Like, why high wattage up here? Expect the high wattage to be, well, it can be in the screen circuit somewhere, in the radio, just anywhere they want to put it. This could be it right here. But generally, they're kept down by the power supply, down in, down around here. Let's see, I don't see any really high wattage resistors down here. Well, here's one. A little bigger than most. 27K. Well, generally the parts look to be in good shape. Nothing too surprising. Oh, here's this. Here's this thing. What is going on here? What is going on here? What is going on here? What in heaven's name is all that? Hey, what do we got here? So yeah, there's a really stiff wire running through the back of the radio and just popping out the end here. And then we got this thing. Is this tied to the wire? Or is it just on the insulation? Green wire. Ooh. Green insulation. So the green wire is, it comes around the back, and it looks like these two shorter wires are just end twisted here. What the heck is this? So first, when I see this twisted wire, I think another gimmick, but I've never seen one this big. And it's going right into the front end of the radio. Wow, okay. Way down in there somewhere, and the other one's going way up in here. And then they're twisted and brought out to nowhere where the ends are connected together. I don't think they're connected to this wire. What the heck is that? So wow, okay. I don't know what that is. That's that's weird. Definitely in the book of weird. I'm gonna really peel this off here. Let's see what's going on. No, it's not connected. I don't know what. Hey, there's another one down here. Green wire with the black one wrapped all around it. Where's it going? Does it just kind of go to a stupid place? It comes all the way down. Oh, goes out to the volume or tone controls. So they're trying to wrap this to make it less susceptible to picking up interference. Like these ones, this one's wrapped a little bit here too. So it's kind of a standard procedure in here. But is this really? Is this real? Is this for real? Well, if it is, it will show up on the schematic somehow. They'll have it somehow. What would it be? I don't even know. That's weird. Yeah, maybe a schematic's the next thing to look at. Oh man, 45 minutes already on this. yeah, why don't we take a peek at the schematic and call it a day. Okay, here's the schematic for the radio. This is probably the missing tube here, 6A8. 6F6 output tube. 6F5. I think that's a little bit of a rare tube there. These are all a little rare because this radio is old enough that it's using older style tubes, an older vintage of tubes, if you like. So these radios are a little harder to make operate well. Of course, you know, as time went by, things were improved, technology improved, tubes improved, everything improved, and it makes the sort of the stable operating zone of the radio gets bigger and bigger. I guess that's the one way to put it, I guess. What they've done in this schematic is they've darkened up the signal path. They've heavied it up here. That's what it looks like to me, to help you trace it. The actual signal, C note, about these two resistors. Here, no, I'm not sure what. Well, I'm not sure what they've heavied up. What have they heavied up? They've heavied up the B plus supplies. That's what it is here. They're showing the extent of B plus throughout the radio. Yeah, that's what it is. 456 IF frequency. Oh, look at this. They have a chart of socket voltages. That's really helpful. September 22nd, 1936. So there's no question about the date. So here's the note. I think note D. Note D. In receivers having serial numbers below 332599. Well, this one certainly is below that, isn't it? Let me look. The number is way smaller. Just a second. 64222. 64222. Yeah, it's way below this number. So this is the case. In receivers below this number, this resistor is omitted in the screen grid of the 6K6. And the 6A8 receive their current through a 31,000 ohm 1 watt carbon resistor. That's probably that resistor I was talking about, connected to the screen grid of the 6F6. And no, it's nowhere near the 6F6, but okay, well, we won't worry too much more about it. In addition, resistor 66 has a rating of 30,000 1 watt. Okay, so something to consider that this is the case with the radio I have. Connector removed when doublet antenna is used. So a doublet is a balanced antenna like a dipole. And what we noticed on the back of that radio is a screw is missing and a wire is protruding where the screw was, right here. That wire, where does that wire go? I'm looking at it now. So that wire that's protruding doesn't go to the chassis. What has happened here? Oh my gosh, I just saw something. Stop this, get back to the camera. Maybe you noticed this. Well, I just didn't get my eye there. I mean, not only is this screw thing missing, but what happened to the wires that are hooked up here? Are they these? What did somebody do here? Did they try to turn this into the antenna? Feeding it feeds into a terminal on this switch. Goodness knows where that's going. What the heck did they ever do here? Now, when I see something like this on a radio, the first thing I think is, what kind of a crazy fool did this? And then I stop and realize I'm a crazy fool in that respect. What did somebody do here that they thought was valid? That I should realize may be valid also. As weird as it looks. Cut wires, this thing stuck in the back. This looping here, you know, like these almost guaranteed these two wires came out here. I mean, look at. Why would somebody cut them away? It would be, oh, I gotta take everything back. Everything has to be undone here. everything has to be undone, because back here, I just noticed, the G is on this terminal. This is the ground. This is the other. And this is the antenna. It has an A on it. So what's happened is the screw is broken off, and they've managed to get this wire to stick out. So this is the antenna connection. And normally you would short these two. So what they've done is they just shorted them back here. That's all that's happened here. Nothing has gone wrong. You see? There it is. There's the truth of what I just said. That you first look at these things, you think some crazy fool has done something, but unless you want to consider yourself a crazy fool too, this is done by a highly intelligent, skilled individual. Okay, well, that answers that whole puzzle. The puzzle no more. We'll go back to the schematic and finish off here. So, okay, let's go through the power supply. So we have a 1 amp fuse, not a 20 amp fuse. We have a capacitor to the chassis. The chassis symbol is drawn upside down from the modern way of doing this. Look at that, it's upside down. That's the on-off switch. Then we go through the transformer. We have a winding for the heaters. One side grounded. Probably in every tube socket, one of the heater pins is grounded to the chassis, and the other one's on a wire. Probably the case. This is just the filament heater for here. Oh, they're showing us to have a cathode, but maybe that's symbolically what they're doing. I don't think 5Z4. I don't think there's a cathode, but maybe there is. I don't know. Usually isn't in a rectifier tube. Face of socket. So this is the speaker plugs in. I didn't think it plugged in. Wait a minute. Who are they kidding here? Trying to pull tricks on me? No, there's no plug on the speaker. What's that all about then? How come they got this whole deal here? Huh. It's kind of odd that this would be on the schematic, but it actually doesn't exist in the radio. They're showing 3 wires coming out to the speaker. You got a box here. I guess it's just trying to tell you this is the speaker. And you've got it says hot right there. I think it's 1230 ohms, 50 ohms. This is the voice coil here. I believe they're trying to show, and this is the field coil that generates the magnetism for the speaker. Okay. Great. Now, where are all the filter capacitors? This one here. 16 microfarads, what it says there. This one says 8. Bet you wouldn't be surprised. There's one more here. This is probably it here. 4. I don't like how they've drawn them, but that's what they've done. Look at the biasing of this tube. Not done by cathode resistor. Must be done by what's going on here. This must be the tone control, and you're just dragging some treble, throwing it away, and adjusting how much you're throwing away. Volume control is here. Okay, so look at the detector for a minute. See, it's using both halves of the tube. Okay, so the audio will be down through here. There's no capacitor here. Oh, here it is. Here it is. That's to drain off the RF and to give a good RF ground here. The audio continues through here. What's this? 0.02, 21. Does this say 21M? M probably means 1,000 in this radio. M means mille in French. Mille means 1,000. If they want a megohm, they'll write MEG beside the resistor. So 21K here. Is there no... Yeah, here it is. This will be the AVC going back. A fairly large resistor here. And then we're, yeah, onto the grid, etc. So as AVC voltage developed out of here, and oop, we have a capacitor right here between the plates. We have one diode working on the audio and the other diode working on the AVC. That's my interpretation of this deal. Okay, just work our way up. So we have one IF amplifier in the usual way. Nothing special going on here. That's a pretty big capacitor, 0.1 at the bottom here. We saw the note. So they're calling this first detector. So in the early days, they thought of this as detecting the antenna signal, and then in conjunction with the local oscillator, creating a new signal, the IF signal. And that's how they kind of viewed it. So they tend to call this a detector also. That's kind of an early term. Later on they stopped calling this a detector, call it a mixer, or I think in Britain it's called a shifter, frequency shifter, which is, it's a mixer and a shifter. It's a mixer being used as a shifter. It's a shifty mixer. That's what it is. Down here through the coils, just 1 second here. So these are the oscillator coils here, and all the little adjustments for them. 4 bands. These are the antenna coils. No, take it back. Not the. These are the you can call this intermediate coils between the RF tube at the front, and the mixer has a RF tube at the front, so that makes it a little bit of a better radio. And it has these tuned coils, and this guy too, for the for tuning against the antenna, or at least the input to the radio. So you got 1, 2, 3, 4 tuned circuits. Better than many radios. Okay, more notes here worth reading. Important. Use a high resistance meter, 1000 ohms per volt. Note A, grid bias for the 6F5 is minus 1.3 volts measured across resistor 60. B, grid bias. So they're showing how to measure grid bias for the 6A, 86K 7s. And the anode voltage of the AVC section, oh, so there you are, I was right, AVC section of the 6H6 is minus 3 across these resistors. Note C, the grid bias for the 6F6 output tube is minus 19 volts measured across series resistors 59, 64, and 60. 59, 64, and 60. 59, 6F6, 59, 59, 64, and 60. Oop. What are you measuring there? You're measuring the minus 19 measured across all those? 240, 25, and 18. Well, what point is this? So what they're doing here is a trick to produce a negative voltage relative to the chassis. So they put a voltage divider on the output of the rectifier, and then they attach the chassis or the negative return or ground or whatever you want to call it into the voltage divider. And the result is the chassis is running a little positive to the bottom of the power supply. Bottom of the power supply is then used as a negative source for grids. That's what these guys are doing. Then where's the? I wouldn't believe what I'm saying. Well, these are all hooked up to grids. Yeah, they're all hooked up to grids. You're getting some kind of grid voltage here and here. And you're getting 19 across the whole shebang, which is being applied right there, right through there. Okay. This is a pretty important arrangement. I mean, if there's something going wrong down in here, you've got wrong biases on tubes all through the radio. But this is a common technique for producing a fixed bias. So they have a fixed bias going to these front tubes, and then on top of it they have the AVC voltage. So there's a minimum bias on these tubes, and then the bias can be made more negative by additional AVC pressure or charge coming in. And is it going to come in on the high side of the high resistor? Yeah, and there's another one here. Range switch shown in shortwave position. What's this range switch? Now, we usually use the word band, but sometimes the word range can be used for the same thing. In shortwave position, well, isn't there like 2 or 3 shortwave positions here? Okay, any more to get out of this thing? Way down here. Prices subject to change without notice. Oh, they got the actual price of the parts in here. Oh, what happens if we need a new light? 15 cents. The whole 3-gang condenser, the great big thing, $5. What's the most expensive thing on the menu? Speakers, $11. $5 for the power transformer. $2 for an output transformer. $2.50 for the range switch. That must be the band switch. Okay, well, hopefully I don't have to buy any of those expensive parts. Good. Let's take a look at the radio again. Okay, what's the plan? What's the plan here? Well, the plan is going to be put a tube in the empty tube socket. Maybe it would be a lot of fun to raise the B+ using a shop supply, fire up the tubes, see what we can get out of this as it stands. I think that would be fun. Before doing any of that, though, I'm going to have to clean this guy up. So I think I am going to do the vacuum brushing, dusting thing. So the next video will be cleaned up, and maybe when it's cleaned up, I'll have different thoughts about it. So thanks a lot for watching the checkout video here, and I certainly aim to get this guy working.